Hello everyone. In this video I'm going to create a problem and show you how to do the two-phase simulation using the volume of fluid model in ANSYS Fluent. Here I will use a 2D geometry. I will create two tanks and I will simulate the discharge of the flow water, liquid water from one tank to other tank using the two-phase simulation. So I will create a sketch in XY plane. Let's create a rectangular. First I will change my units to millimeters. Then I will draw a rectangular. Let's have a distance from the origin. Okay. And second rectangular. Here, then I will create an arc here which will act as a discharge tube. So next I will first let's put the dimensions to these rectangulars. So I want to have the width of this one 200 millimeters, the height to be 150, width of the lower tank is 200 by 200, the size. So radius of let's do let's say 36, 27. So then I will draw a line which will help airflow goes back when flow discharge from the top tank to lower tank. It will help, it will let the air go back to the top tank. Okay, I will go to modify, trim. I will cut out these openings. Okay. Now I will go to modeling and select sketch. Concept surface from sketch and select this sketch, apply and create generate. So we have a sketch which is not closed, so we can find problems. Can go to modify, extend, to make sure that all are connected. Okay, so trim. We have this corner connecting together, so we need to have a distance between so let's the problem is that these two rectangles was connected through this point, so I deleted some of the lines here, so I will draw a line with some distance from the origin, then I will fix the geometry. I will go to modify, extend, trim, so this time it's worked because we had some large distance here, so we can go again to the sketch and reduce this distance between them. So we can select this point to this point, and it's 10 millimeters. Let's put 2 millimeters. So now we have our surface finally. So I will close the design modeler. I will open the meshing. And now we have our geometry here. I will not use any specific settings, just I will define the size of the mesh. I think 3 millimeters will be okay. Let's generate the mesh. So as you can see, I have this vent tube here, so I put this vent tube here closer to this discharge tube, so there will be a lower pressure area because of the movement of the like discharge of the water, so it will create a suction in this tube, and you will see that later, that as the discharge flow goes here, there will be some suction and some circulation of the water through this tube. Because of that, I put the vent closer to this one. If you don't want to have that circulation, you can put the vent from here. So now we have our mesh. It looks like it's a pretty decent mesh, so we will update the mesh. So I will close the meshing and open the Fluent. So my PC has 8 processors. I will use 8. Make sure this is double precision, it's automatically 2D because we have a 2D geometry and mesh. So I have a Intel processor with Intel MPI installed, so if you don't make you're not sure which MPI is installed, just leave it as default. So I will start Fluent. So what will I do? I will use the volume of fluid simulations. Using the volume of fluid model, I will use the laminar model to expedite our simulations. So you can use turbulence. You need to see if this the flow has a turbulence nature or not. You need to look for the Reynolds number. So this is a transient simulation which has gravity. This direction was y direction, so we will have minus 9.81 for the gravity. So first I will go to materials, create change from the Fluent database. I will go down, liquid, H2O or water, copy, close. So we have water and air. So I chose the material first. I imported water first, so when I use the multi-phase model, it will automatically assign the second phase to water. So I will use the volume of fluid. So I will double click on this one. So I will use the implicit model with sharp interfacial anti-diffusion and implicit body forces. So it's better to read the Fluent user guide about this settings, what's the difference of these different types of the volume of fluid model. So I will click OK. So I will check about the phases. The phase 1 is air. And the phase 2 is water liquid. So next, since we don't have any inlet outlets, so we don't have any settings for the boundary condition, one thing we need to do first, let's initialize our case. Then let's do first, after initialization, I want to fill out the upper tank with water. So what we can do is, in the previous models there was some region patching, so in new Fluent this is hidden. What you can do is go to command window, type mesh, then in the mesh window go to adapt, and for the adapt is revert to previous version. So I will use this command. So as I press enter, you can see there's a mark adapt option is appearing here. So I will go region. So if you remember, the it here is the 0 point, so I will mark a region from 0 to 1 and from 0 to 1 in Y. So I will mark this region. So I will go to initialize, patch, then I will choose the phase 2 volume fraction 1 in the marked region here. So I will click patch. So I will go to graphics. I will create a counter of phases, a volume fraction of the phase 2. So in the 2D simulations, it's better if you want to have a smooth counter, it's better not to select any of these and just press display. So you can see that for the positive y's and positive x's, the volume fraction is 1, the others are 0. So when we press initialize, it initializes whole system with air or phase 1. Then we mark this positive y and positive x region and patch that region with the volume fraction equals to 1 for the phase 2, which is water. So it's kind of filling the upper tank, this marked region, with water at the time 0. So if you want to see how the water is discharging during your simulation, we can create solution animation. So I want to update every 10 time step, because if you do every time step, it will slow down the simulation by the counter number 1. So and just simply click OK. So go to the run the calculations. I will use the variable time step. Then go to settings, and minimum time step 1 to the minus 5. The maximum time step is 0.001, and I will leave others as default. Click OK, and the initial is 10 to the minus 5. Number of time steps 20,000. So then I will click calculate. So it will take a very long time, because it's a kind of two-phase simulations, and I will let a couple of steps running, then I will pause the video, and then come back to you later to show how to use these animations and this results and post-processing. I just wanted to show you in the middle of the simulations, every 10 time step it will update this counter as an animation. So you will see later you can play and export this animation as a video. So as flow is discharging during the simulations, before stopping this, finishing the simulation, you can see kind of the post-processing results using this solution animation. So you can see it's like 19,941, and when it comes to 40 it updates, because I have set for every 10 time steps. So I will come back when the simulation is done. So I continued the simulations more than 20,000 time steps, because I needed to check that the discharge is complete. So I went up to almost 91,000 time steps. So you can see it's completed discharge from the animations. If you want to play the solution animation, you will go to results, animations, solution animation. So here you can play the animation. You can see how it's discharging. So let's stop, and you can, if you want to run faster, you can increment 10 time steps and use the fast forwarding. So you can see that the discharge of the flow from the top tank to the lower tank. So some fluid mechanical points in this video. As you can see, first the head is higher, so we have a bigger jet here. As it goes lower, the height of the water on the topper tank, and we have a smaller jet in the bottom. And also you can see, if I go a little bit back to stop, go to the beginning, so let's increase. Okay, we need to set this one to 1. So you can see as it's discharging, it goes down. There's a void area. It's kind of creates the negative pressure here, so it kind of there's creating some suction here. As you can see, some of the water goes down and circulates back to the upper tank. So, but when the head or the height of the water is lower, it decreases this jet far from this suction. So we will have almost no circulation later in the simulations. So one way to export your animations in Fluent without going to the post-processing is write record format. So you can create frames. If you want to do very high resolution, you can use higher resolution, set your own resolution, or you can create a MPG file and click write. It will take a while. I have already created this MPG file. As you can see, you can play this animation. Okay, thank you everyone for watching this video. Please subscribe to our channel and like and share our videos. Thank you.